Hello and welcome back. We are in our third week of e-learning and we are getting through this. We're keeping strong. I hope all of you are staying inside and staying safe. I hope everyone, this video finds everyone in decent spirits. I know if you're anything like me, time has lost all meaning, but try to keep a schedule, try to keep active. Don't be spending all your days doing this, but come inside, make sure you do get it done. This stuff is important. It is part of your grades, just like it would be otherwise. So come on, keep up with it, keep doing it. Otherwise, you got this. So this week, what we are learning about acids and bases. One of the more interesting topics that we're going to cover this year. Now, I know many of you have these preconceived ideas about what an acid is, what a base is, how strong or how an acid reacts when it deals with stuff. And a lot of that has to do with movies. There's a specific acid that I like to call animaic acid, aka not real. That's the type of acid that you see something in and it just automatically disintegrates and just it's gone. That isn't real. That is a very um, wrong interpretation of what an acid actually is. Now, that effect can be seen. It does happen, but not in that type of time span, not in that it usually takes several days if not weeks for that type of deterioration to occur. So, let's talk about what an acid actually is. So, what is an acid? An acid is defined by a pH. I know if any of you have a pools or anything like that, you've dealt with pH before. So, an acid is defined as a pH less than 7. Now, we can go into a whole thing about what is pH. Basically, it's just how acidic or basic something is. If it's really acidic, the smaller the number. So, if it's at 7, it's basically not an acid anymore. It's pretty low grade, not much. If it's below 7, the further lower than 7, the more acidic that it is. We can even have things that are negatively acidic. Those are really nasty things. It's not something that you're going to encounter in your day-to-day life, but they do exist. Acids neutralize bases. They are opposites. They're polar opposites, so one will neutralize the other. If you have equal quantities of both, they're both going to turn out being nothing. Acids form H3O plus ions in solution. Those are called hydronium ions. Hydronium is H3O plus ions. Um, that's just a good thing to know. We'll get more in depth in this if you go into Chem 1 next year. For now, all you need to know is that they form hydronium ions. Acids are corrosive and react with metals to form hydrogen gas. That hydrogen gas is what can cause some issues. If we had in Chem 1, we actually do this lab where we make hydrogen gas for our gas laws, and we get to play with that a little bit. But that's a good way of finding an acid. Acids are very good conductors of electricity, and they taste sour. Now, an important point here. Yes, we never put anything that's in a lab in our mouths, but that doesn't mean that you never have tasted an acid before. If any of you have ever drank a pop or anything that tasted sour, like bitten into a lemon or a lime, that is actually an acid, mostly citric acid, but those do count as acids themselves. So, there are two types of acids. There are weak acids and strong acids. Weak acids are defined as not ionizing completely. So that's the majority of acids. Most acids do not ionize completely. What that means is that they don't completely dissolve into solution the way they're supposed to. And then there are strong acids that ionize completely. Hydrochloric, nitric, sulfuric, hydroiodic. There's only actually 7 strong acids in existence currently. Now, an important point to make. Just because we say that a strong acid is strong and a weak acid is weak, that does not mean that a weak acid cannot be more dangerous than a strong acid. Quite the opposite, in fact. There's actually more dangerous weak acids than there are dangerous strong acids, just because things like concentration and how it affects our bodies. But remember, weak acid does not ionize completely. Strong acid does. There's a whole bunch of common acids, such as hydrochloric acid. That's the stomach acid in your stomach. Hydrosulfuric acid or sulfuric acid, which is in your car batteries or most batteries actually. There's nitric acid, which is found in most explosives like fireworks and or gunpowder. Acetic acid, which is used in vinegar. If any of you open your cabinets, you'll find some vinegar in them somewhere. And carbonic acid, which is found in all carbonated drinks. Anything that has a fizz to it has carbonic acid. Um, and then phosphoric acid, which is used for a lot of different types of flavoring. So these are just some common acids that you can find just about anywhere. So when we talk about acids, we have to talk about bases. So bases are the opposites of acids. So when acid has a pH lower than 7, bases have a pH greater than 7. Bases feel slippery when you touch them with your skin. If you don't believe me, go put some soap on your skin. Does it feel slippery? Cool, that's because it's a base. It's actually being really, really slippery. It dissolves fats and oils. That's why we use soap when we are cleaning our kitchen stuff out, because it actually dissolves the fats and oils that are still on there. They form OH ions. Now, if you remember way back when we were doing our chemical reactions, you saw OH as a hydroxide polyatomic. If you don't remember the words I just said, that's absolutely fine. Just know that it forms OH ions in solution. It neutralizes acids. Remember, if one acids neutralize bases, bases neutralize acids. They do it to each other. It happens at the same time. And it is bitter tasting. So while acids are sour, bases are bitter. So if it's one of those two, it can actually help you tell what's an acid, what's a base. So a bunch of common bases. We have sodium hydroxide, which is lye, which is found in almost every soap or drain cleaner, anything that is used to clean something heavy duty. Magnesium hydroxide, which is what is found in your antacids, tastes kind of like chalk. Aluminum hydroxide, again, antacids, also in your deodorants. If you use antiperspirants, then you will find the aluminum hydroxide. It actually helps adhere to your skin a little bit better. And ammonium hydroxide, also known as ammonia, which is used as a cleaning agent. All of these are common bases that you can find in your house, most likely right now. So, I know I was talking about neutral solution. So what is a neutral solution? So a neutral solution is a solution with a pH of 7. Means that it's right in the middle of acid and base. It's not leaning one way or the other. It is 7. Neutral solution is characterized as having a balance of H plus and OH minus. Not that it doesn't have these ions, but that it has the same amount of each of them present in solution. Bases will neutralize acids and acids will neutralize bases. If in nature there's only one of the most common substances that is considered neutral or considered to be at or near 7, which is water. Now, it's not always at 7, but for our purposes, we can assume that it's at 7 most of the time. Distilled water, which would come out of my tap on my sink, that is supposed to be at 7. It's not always. There's some other circumstances, but most of the time it's around 7, making it a neutral solution. So this is just an idea of the pH scale. The pH scale used to go from 0 to 14. It now actually goes to the negative numbers, but it also will go up to. It only goes up to 14. So it's 14 and below. It will never go above 14, but it will go below 0. Just some simple things. Lemon juice is a pH of 2. Rainwater has a usual pH around 5 to 6. Human blood actually has a pretty solid pH of 7.5. Baking soda is a very good base of 8.5. Bleach is a base of 12.5. Here's just another pH of common substances. Very simple, very, very common for you. I will make sure to post this for you to look at. pH paper. Some of you might actually have this. If you own a pool or some kind of swimming uh, su- uh, structure, you'll actually use pH paper in testing of the water levels for that. So pH paper changes color to indicate the specific pH values. They'll usually have a little strip. You put it in, hold it for a second, you pull it out, and you can actually test the color that it changed based on the little slip of paper that they give you. Um, pH is usually tried to control. We usually try to control a pH one way or the other. So heartburn is a great way, is just a natural thing that we try to control the pH. When you're planting vegetables and flowers, especially if any of you are farmers, you know that you have to maintain a specific pH value. Fish tanks, ponds, your blood has to be at a specific pH or you won't survive. You will have a very bad time if your blood turns suddenly acidic. Um, is actually a disease. I think it's the iron kidneys, where they actually have to drain your blood every few days and actually recycle it to make it less acidic on you. It's not a great time. Acid rain. So, I know many of you have heard of acid rain before. It's a horrible thing. What it is it's pollution in the air that usually comes from burning fossil fuels, so sulfur dioxide, etc. Basically makes a bunch of different acids with the water that's in the clouds. So, you'll have these contaminants like CO2, sulfur dioxide, nitrogen dioxide, and they combine with the water to make an acidic solution that will fall to the earth and that. Now, this is normally a natural process, but because of the pollutions that we have released as humans, uh, we have actually ramped up this acid pollution to the point that we've actually destroyed a lot of our own structures and causes a lot of climate change that wouldn't otherwise happen. I know when we talk about climate change, we usually focus on global warming, but that's not the only change in the climate that we are affecting. We're affecting a lot of different changes through all the stuff we do. Burning fossil fuels isn't just bad because it's warming the earth, that happens naturally. But because of the pollution and everything else we're releasing, we're actually making it a lot worse than it ever could be by itself. Rapid changes in pH can kill fish and other organisms in lakes and streams. Soil pH is affected and can kill plants and create sinkholes. So, all of these are caused by pH and acid rain. This is what happens when you have too much pH or when you have too many pollutants in one area falling to the ground in form of acid rain. This is not good. This is why we need to try to limit the amount of pollutants that we release up into the world. Your pH is you have a pH in your digestive system. Has each one of you has a mouth. I've heard all of you speak before. The pH of your saliva is actually around 7. It contains amylase, which is an enzyme that helps break down carbohydrates and sugars, which allows you to have that 7 pH. Your stomach has a pH of around 2, uh, with proteins that break down amino acids and all that, and small intestines with a pH around 8. Um, it allows to help break down everything else and also helps to neutralize the acidity in your blood system. So, for your assignment, I'm going to have you um, fill out the answer. On your worksheet, I want you to put your answer to this problem. Put the following solutions in order from least acidic to most acidic. So make sure that you do that. Remember that acidity is the more acidic it is, the smaller the number. The less acidic it is, the higher the number. In the meantime, stay inside, stay safe, do everything you can to flatten the curve, Be healthy, guys. See you around.